Okay, and now we start section 2.2. I do believe this might be a one video thing. So we have trig functions of non-acute angles. So you're going to find trig function values using the reference angles. And then the second part is we'll find angle measures given an interval and a function value. So reference angle. On a reference, the first thing I'm going to throw out there is we are going to talk about this tomorrow. Okay, so reference angles. For an angle theta, written theta prime is a positive acute angle made by the terminal side of angle theta and the x-axis. Reference angles. Let me identify this. A reference angle is between 0 and 90 degrees. It is not 0 degrees. It is not 90 degrees. It's somewhere in between. So all quadrant 1 angles, all quadrant 1 angles are reference angles. So that's something to know. So if they say, what's the reference angles to a 45-degree angle? It is its own reference angle. Okay. So if I'm in quadrant 2, then theta prime equals 180 minus theta. Example, if they say 120 degrees, you do 180 minus 120, you get 60. It throws you into quadrant 1, and then you can use your little card that gives you all of the trig functions on it. You just have to identify the fact that you're in quadrant 2 and you have some negative values. Now you can also find theta using your reference angle. So theta also as well would be theta equals 180 minus theta prime. Okay, so quadrant 3. So if you're in quadrant 3, then your reference angle would be theta minus 180. Now again, you can find theta here by doing theta equals theta prime plus 180. That's for quadrant 3. And quadrant 4, we're down here. Theta prime equals 360 minus theta. And again, you can find theta this way. It would be theta equals 360 minus theta prime. Okay, we are going to talk about this in class tomorrow, so if you're sitting there going, wait, I still have questions, great. I will go, especially this page. We want to go over it some more tomorrow. Okay, so find the reference angles to the following angles. So on this one here, find the reference angles. So 97 degrees, 97 is in quadrant 2. So this is where I'm going to come over here and do this little thing. Remind you guys, 0, 90, 180, 270. Full rotation is 360. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So our angle is 97 degrees, so our reference angle is going to be 180 minus 97. So theta prime equals 83 degrees. You should always, 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 always get a quadrant 1 angle out of this. So the next one. Angle is 46 degrees. Well, this is quadrant 1. And quadrant 1 are reference angles, so it's 46 degrees. There's nothing to do there. 76. Now this really is in quadrant 4, but I want to point out to you that this is a negative value, but the number is less than 90. So just take the negative off. Theta prime is 76 degrees. Remember, the negative only told you which direction to go. The angle is still a 76-degree angle. Now, the next one, 1387. Let's see, what quadrant are we in? Well, we got some work to do here because we have coterminals going on. So if I was to take, let's work some over here, 1387 and divide this baby by 360, we would get 3 point something, 3.85, something, 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 something. So I know it's 3 rotations around. So 360 times 3 is going to give me 1080. 1387 minus 1080 is going to give me an angle of 307. So my reference angle here, I got to move all these babies to the side. They're in my way. Okay, so our reference angle here, since we're in quadrant 4, 307 degrees, quadrant 4, this is going to be 360 minus 307, which gives us an angle of 53 degrees. So our reference angle here is 53 degrees. Okay, next one. Should I sit there and tell you guys figure this one out. So we need to know what quadrant we're in. Now this is a negative angle, so be careful with this one. So same thing. 1120 divided by 360 gives us 3.111111111, keeps going. But now this is a negative angle, so we want to do 360 times 4. So we get 1440. And we subtract that 1120 off of it, and we get an angle of 320. Look at that, we are in quadrant 4. So again, 360 minus 320 gives us a theta prime of 40 degrees. Okay, so this is a reference angle. Let's recap it a little bit. Reference angles are always, always, always in quadrant 1. Do not confuse these with coterminal angles where you just add 360. We're always trying to get back to quadrant 1 on these. Okay, so next little bit. The use of a reference angle allows us to find the value of any trig function with reference angles of 30, 45, or 60. Those are on your little card. So we find the missing values. Okay, theta is 135 degrees. So we go, oh, this is quadrant 2. So 180 minus 135 gives us 45 degrees. There's our reference angle. So you look at your little card and you go, oh, look, this theta is 45 degrees, or actually we gotta be careful. Let's not forget that all students take calculus. All students take calculus. And we're here in quadrant 2 where sine is positive. Sine is positive, which means cosecant is positive. Cosine is negative, cotangent is negative, tangent is negative, secant is negative. Let me pause this for a second. Okay, sorry about that. Had to take a quick little break. Anyways, back to, we're in quadrant 4 where sine is positive and it's reciprocal cosecant. I will apologize for the order in these, which these are written. I didn't catch it before, so I had to leave it. So, but we're at a 45-degree angle, and sine at 45 degrees is radical 2 over 2. All you're doing is looking at that card. You're going 45 degrees, and you're just grabbing your sine, cosine, all of those values straight down. Cosine, radical 2 over 2, but we already marked the negative because it's in quadrant 2. Tangent is 1. Cotangent is the reciprocal of tangent, 1. Secant is reciprocal of cosine, so we get radical 2. And cosecant is the reciprocal of sine, again, radical 2. These are coming straight from the card. If you can memorize that card, this is going to go much, much faster for you. Okay, so let's try a couple more. We got 2 here. Oh, we got 3 here. Okay. So the first one, we want sine of theta, cosine of theta, tangent of theta. And then cosecant of theta, secant of theta, and cotangent of theta. So 300 degrees, this is quadrant 4. So to get my reference angle would be 360 minus 300. So theta prime equals 60. So now keep in mind, quadrant 4, all students take calculus. C for cosine. Cosine is positive, which means secant is positive. The other 4 will be negative. This is the number one mistake you're going to make, is you're going to forget your negative sign. So be very, very careful. So go to sine. Sine of 60. Go down your list on your card. And sine of 60 is radical 3 over 2. Cosine is 1/2. And tangent is sine over cosine, or negative radical 3. Cosecant is a reciprocal of that, but again, you should just already have it on your card. So 2 radical 3 over 3. Reciprocal of 1/2 is 2. And reciprocal of radical 3 is radical 3 over 3. And done. All right, why don't you pause this and then try the next one. See if you can figure out what quadrant you're in and go. So pause this. All right, so let's go back to this one. 750, this is 2 rotations. So if I subtract 720, I get 30 degrees. This is not my reference angle, this is my coterminal angle. 30 degrees, but 30 degrees is less than 90, so I don't need a reference angle for this one. So I have sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And since this baby is in quadrant 1, everybody's positive. You just got to go to the card and just read it down. So sine at 30 is 1/2, which makes cosecant 2. Cosine is radical 3 over 2, which makes secant 2 radical 3 over 3. And tangent is radical 3 over 3, which makes cotangent radical 3. Quick, simple, to the point. Okay, let's throw a negative one on there. Again, pause it, see if you can do this on your own before you look to see what I did. Okay, so how did you do? Have to do that reference angle, not reference, coterminal angle first. So 360 minus 150 gives us 240 degrees. This guy is in quadrant 3. So 240 minus 180 gives us a 60-degree angle. That's not right. 0, 5, 240, 240 minus 180, okay. All right, there's my mistake for the day. I knew it wasn't something with, hey, at least I caught it. I get to claim that one. I caught it. This is not 240. Don't ask me where that 4 came from. It is 210. 210. And 210 minus 180 is not 60. It is going to be 30. So our reference angle here is 30 degrees. So we do sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta and cotangent of theta. Now, keep in mind that negative 150, we're really at 210, quadrant 3. All students take, it's the t, so tangent. These two are positive, so the other 4 will be negative. Got to make sure you throw those in there. And we're at 30 degrees, so sine at 30 is 1/2. That gives cosecant a value of 2. Cosine is radical 3 over 2, so secant gets 2, radical 3 over 3. Tangent is radical 3 over 3, and cotangent is radical 3. How did you guys do? Okay, so we're almost done with these. Almost done with these. See how we're going. Hope you guys are going, this isn't too bad. Reference angle is a big one. You've got to remember these reference angles. We will use these again and again and again. Okay, so let's use those cards and see how you guys do. Can you claim these to be true or false? Evaluating expressions with function values of special angles determine whether each statement is true or false. Sine of 30 plus sine of 60 equals the sine of 30 plus 60. Well, this would become the sine of 90, because you have to do the parentheses first. So, sine of 30, 1/2, plus the sine of 60, which is radical 3 over 2, equals the sine of 90, which is 1. And I hope you guys can see that radical 3 plus 1 is not going to give you 2, therefore we will not get 1. So this is a false statement. Now, if you want to throw that in the calculator, you can. This is what you're going to get. 1 plus radical 3 all over 2. And they are not the same. Okay, cosine of 60 equals this mess. Cosine of 60 is 1/2 equals 2 times the cosine of 30. Cosine of 30 is radical 3 over 2. But I want to square that. Minus 1. Please don't stop here and go, yep, nope, let's do the math. So 1/2 equals 2 times, square this, the radical cancels the square, so we're left with 3, and 2 squared is 4, minus 1. So 2 times 3 fourths. Really, the 2 is going to cancel with the 4, and you're going to get 3/2 minus 1. And 1/2 equals 3/2 minus 1 is 1/2. This one is a true statement. Okay, so why don't you pause the video and try the last one and see how you do on this last one. Okay, so let's see how you did. So sine of 2 times 30 is really just the sine of 60. So this gives us radical 3 over 2 equals 2 times the sine of 30, which is 1/2, times the cosine at 30, which is radical 3 over 2. But we can do the math right here. Half of 2 is 1, so this is just 1. So we get radical 3 over 2 equals radical 3 over 2, which is a true statement. How did you do on that one? Did you get it through okay? Okay, this is where I would want to stop, but I'm looking at what we have left on notes. I haven't quite gotten to even 25 minutes, so we're just going to finish up this section. So in the next little bit, finding angle measures given an interval and a function value. So now you're going to have to read your chart backwards, I guess is a way of putting it. You have to determine the quadrant that your angle can exist in. It can exist in more than one. Remember, it's positive in 2 quadrants, negative in 2 quadrants. Find the absolute value of the function value. Determine the angle from the absolute value of the function value. Anyways, get your reference angle. And then sketch the 2 possible reference angles to determine the angle measures. You don't do step 4. I'm not going to worry about step 4. It's can you get me to those 2 angles. So let's try these out. So find all the values of theta if theta is in an interval of 0 to 360 and has the given function value of radical 3 over 2. So you look at your chart and you go cosine, you go over to radical 3 over 2, and then go up, find out what your angle is. Well, the angle who has a cosine value of radical 3 over 2 is 30 degrees. Okay, 30 degrees. I think I did step 2 before I did step 1. Actually, I did step 3, whatever. Okay, cosine though, since this guy is positive, we look at our quadrants and we go, well, cosine's positive. Remember, all students take calculus. So C here and the A here gives us a cosine. So we know we're not in quadrant 2, we know we're not in quadrant 3. We're in quadrant 1 and quadrant 4. Well, the quadrant 1 angle was the easy one. It's equal to 30 degrees. But guess what? Your reference angle is also 30 degrees. So now for our quadrant 4 angle, we do 360. Let me erase this. Theta equals 360 minus your reference angle. So that would be 360 minus 30. So this gives you in quadrant 4, theta equals 330 degrees. And there's your 2 answers for that one. So let's try this one. Now this one has the absolute values, so it says determine the quadrants. So we come in here. All students take calculus. Well, this negative, so we know we're not in quadrant 1, and this is cotangent, which goes with tangent, and so it's not in quadrant 3. We're either in quadrant 2 or quadrant 4. So, first thing we need to do is look at our chart, going, I need the angle whose cotangent is radical 3 over 3. And you go through that, and you should find that your theta prime is going to be 60 degrees. Because we're looking at cotangent, not tangent. Cotangent at radical 3 over 3 is a 60-degree angle. So quadrant 2, to get to quadrant 2, theta equals 180 minus 60, which is equal to 120 degrees. And in quadrant 4, theta equals 180, I'm sorry. Let's reset. I'm looking at the words above me. 360 minus 60, which gives me a 300-degree angle. And there are your 2 answers there. We'll go over more of these in class if you're going, well, wait, because sometimes it's just a matter of doing 1 or 2 more, and then you're going to go, oh, so got this. So we have one more problem to do that will be typed on your homework. And I am not quite I'm down to 13 seconds of the time I wanted. So we won't get in there. Here you guys go. Find the coordinates of the point P on the circumference of the circle. Okay. Well, down here we know that we have negative x and negative y. Not a problem there. We have negative x, negative y. So we know both of our values are going to be negative over here. But the question is what are those values? Okay, well, we're in quadrant 3, and we need our reference angle. So this is going to be 225 minus 180, which is going to give us a reference angle of 45 degrees. Now keep in mind that this is your R value, and this is your cosine sine. So at 45 degrees, my cosine and sine value is radical 2 over 2. This is at 45 degrees. But I'm in quadrant 3, so they're both negative. Okay, so we put negative signs on. Negative radical 2 over 2, negative radical 2 over 2. Now, we also have a radius of equaling 10. Now, before you go and say, oh, we're going to divide by 10, no, 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 no. Because we've already cleaned this up for the radius to get that radical 2 over 2. What we have to do now is just simply take our cosine sine values and multiply by 10. So this is going to give me negative 10 radical 2 over 2, negative 10 radical 2 over 2. And don't forget to clean up your fractions. So your answer is going to be negative 5 radical 2, negative 5 radical 2. Now normally, again, I'm going to throw out there that when we're doing sine, cosine, and everything, we're using an R value of 1. So before, this would have given us different things. So just want to throw this out there to you guys to get these out there. So this is what we have. And remember, they were asking you for the coordinates of the point. So since it's a bigger circle, we had to have bigger values. All right. So that takes care of that. And there's you guys' homework. Woohoo, I know you're happy. So good luck on this one. Not bad. 26-minute video.